In this illustration, we intend to simulate low yield point steel plate shear wall with stiffener under the cyclic loading in the Abaqus software. As you observe in the picture, the model is composed of shear web plate, horizontal stiffener, vertical stiffener, flange plate, and connection plate. In this picture, you can observe the laboratory model that will become simulated in the Abaqus software. In this problem, first we will do the buckling analysis of the steel shear wall, and then the hysteresis analysis of the steel shear wall will be performed. In these pictures, the areas where the buckling has occurred can be clearly observed. Actually, the buckling has occurred in the four corners of the steel shear wall. As you observe, the results obtained from the Abaqus software are similar to the results explained in the article. In this picture, the hysteresis diagram gained from the Abaqus software has been compared with those results mentioned in the article. As you observe, the results obtained from the Abaqus software are so close to the laboratory tests. In this picture, the deformation of the shear wall under the cyclic loading can be observed. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Cyclic Behavior Study of High Load Bearing Capacity Steel Plate Shear Wall. I will enter the Abaqus software for simulation. I will click on Create Part. Here, I intend to create geometric shape of the plate. I will select the modeling space as 3D. From here, select Deformable, then Shell and Planar. Enter approximate size equal to 5000 and continue. I will draw a square. In this picture, the size of the shear wall can be observed. The height of the shear wall is 1400 millimeters and its width is equal to 1472. Done. After that, I'll click on Linear Pattern, select Stiffener. Done. Here, I will enter the number of stiffeners equal to 3. Click on this arrow, select this line. I will enter the distance between the stiffeners equal to 350 millimeters and OK. In the next step, I'll enter vertical stiffener into the assembly module. Click on Rotate Instance, select vertical stiffener. Click on Create Section. Continue. The thickness of stiffeners is 12 millimeters. Here I will select the Q345B material. OK. Here select displacement rotation and continue. Here I will select the bottom of the model. Done, and close all the boundary conditions of displacement for it. Then I will click on Create Boundary Condition again. Select Step 1. Select Displacement Rotation. Here you observe the first mode of buckle. Actually, it means that buckling occurs in these areas. As you observe here, buckling has occurred in all the 4 areas having been marked out with red color. And as the Abaqus software has predicted in the first mode of the buckle in these 2 areas, the local buckling would occur. In the next step, we intend to draw the hysteresis diagram of the model. In fact, we intend to draw this diagram in the Abaqus software, in which the horizontal axis will be displacement and the vertical axis will be force. I click on Create XY Data, select ODB Field Output and continue. Here I will select Unique Nodal. First, select RF1 or the same reaction force directed at X. After that, I will select U1 or displacement directed at X. Here I select this node and click on Save. I will click on Create XY Data again, select Operate on XY Data, continue. Here select Combine. First select U1, then RF1 and click on Save As. Here you observe the hysteresis diagram having been drawn in the Abaqus software. I will transfer this diagram to the Excel software. The first column is displacement, the unit of which is millimeter. And the second one is force, the unit of which is Newton. Here, the diagram having been drawn with blue color is the one obtained from the Abaqus software. As you observe, the results gained from the Abaqus software are similar to those mentioned in the article, indicating that the problem has been simulated correctly in the Abaqus software, and as told, the horizontal axis is displacement and the vertical axis is force.